Hey, Heidi ho, and welcome. Okay, so this is chapter 18 dealing with air pollution. It's among the last major topics that we need to talk about for APES. Okay, and with that, ladies and gentlemen, I need to get my keyboard here. And as they say, let's get it started. So, our objective here, we're looking at what are the parts of the atmosphere. Okay, there's different layers, and we have to talk about the ozone layer a little bit, the stratosphere. In terms of the AP exam, there's three main things you need to know. You need to know about the troposphere, which is where we are in. So the air immediately around us is the troposphere, and then there's the stratosphere, and then the ozone layer. And that's pretty much it for the layers of the atmosphere. Let's get going. So we know the atmosphere is made up of layers. Okay. Most of the air is nitrogen gas, and it's not flammable, which is a good thing, inflammable. And 21% oxygen. This is a rough calculation. Now, the water vapor, interestingly enough, it varies. It can be 4% up in the tropics, and it can be 0.01% at the poles itself. Okay, so we have less than 1% as actual argon gas, that noble gas that belongs to the likes of helium and neon and all that. Okay, and then actually the 0.038 CO2, that's what makes up the atmosphere, and that's what got the climate change people all up in a tizzy. By burning fossil fuels, we get a bunch of CO2 that's put out. What I can't quite figure out on this one, guys, is that CO2 is the raw material for photosynthesis. Yeah, photosynthesis by grass and bushes and trees and algae and phytoplankton, which makes up the surface of the world's oceans. They take that, that's raw material, that's practically food for them. Okay? That's a very tiny, tiny amount. Then, of course, there's trace amounts of other gases in there as well. So, we have to talk a little bit about atmospheric pressure, and that's the mass of air per unit area. So, when you look at this diagram here, you've got the altitude and you have the pressure in what are called millibars. Okay. So, being down here, okay, we would be around close to 1,000 millibars, a little bit over. Okay, standard pressure at sea level, to give you an idea. And then naturally, when you're going up, you've got less air pressure pushing down on you because you have actually less air molecules pushing down on you. Okay, so the higher you go, there is less air pushing down on you. Okay, now, if you think here's Mount Everest in this diagram. Now, you got to stop and think about it. There's a certain point for those climbers to go to Mount Everest that they need to wear the oxygen masks, okay? Because the air is so thin up there, okay? That's kind of an important thing. Okay. So, let's look at the troposphere. And this is the big one because that's the one where we are at down here, and it's most of the air mass, okay? And it's definitely involved in chemical cycling, okay? Well, wait, what do you mean by chemical cycling? Think about like the carbon cycle, the nitrogen cycle, okay? Those cycles. And we'll have to go back and we'll have to review those again in time for the exam, okay? But it is there in the troposphere that we have wind, we have thin and turbulent air currents, okay? And it's pretty much responsible for our short term weather and long term climate. That's pretty much where our weather happens in the troposphere, which is the absolute lowest, okay? So if you look down here on the diagram, this is the troposphere. There's Mount Everest. Yeah, you have something called a jet stream, which is a little high up, which is useful for flying. And then these are the main parts that make up the air down where we are at. When you go up into the stratosphere, which is the next layer, you'll notice that there's a few more items in there in the air. But the stratosphere, typically, jets would fly roughly in that area, give or take. And yeah, that's pretty much it. And then like the mesosphere and the thermosphere. Now the ionosphere, this is what allows radio signals to bounce across the world literally. Okay, the ionosphere, um, it allows for things like TV signals, radio signals to bounce. I remember as a kid, I actually received from Radio Moscow on my shortwave radio. Okay, my Sanyo boombox. I don't know where it is today. Today I've tried and I have had no luck finding it. It was the Voice of America coming to you from Moscow. Okay, so ozone formation. The ozone is a very important thing. And the fact is that 95% of the UV rays are not reaching the surface because the ozone layer absorbs most of the UV rays. Why would that be important? Well, we need to understand what the ultraviolet radiation is. Okay, it's very short wavelengths, and because of that, it has a lot of energy in it. You want to go get tanned? That's the UV radiation that makes your skin get tan. Okay, that is also the same radiation that causes your skin to get sunburn. And for people of lighter skin, if you're not used to being out in the sun, getting sun, you actually sunburn a little bit faster, okay, because of your lighter skin. That's just the way it is, okay? So when we look at the ozone formation, really what we're seeing is 302 plus ultraviolet gets us 203, okay? That's what's happening. So this is where we get in the formation of the ozone layer. This is what happens for that. And that's kind of important because that's what allows the UV radiation to be absorbed. Okay. And we're going to move on to our second thing here. So we looked at the parts of the atmosphere. We looked at the ozone layer and why do we consider it so important? We will revisit that at the end of the chapter. Okay. Now, for this one, we got to talk about pollutants. And I think I'm going to make that a separate video for that one because that's quite a chunk of the chapter. All right, I'll catch you guys on the flip side.